Hello, this is Mrs. Taylor, and I'm going to introduce you to the definition of a derivative. So formally, the definition of a derivative is defined in this way. The derivative of the function f with respect to the variable x is the function f prime, whose value at x is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h, provided the limit exists. So in class today, we learned the slope of the secant line was also the average rate of change. We learned the slope of the tangent line was the instantaneous rate of change. And we learned that you can find the slope of the secant line using this difference quotient here. And then when we have the limit as h approaches 0 included in that difference quotient, then it becomes the instantaneous rate of change or the slope of the tangent line. So what we're doing now is we're formalizing that slope of the tangent line concept into the idea of a derivative. And so it's still the same limit we were working with in class today. It's just now we are formally calling it the definition of a derivative. A couple of notation things. The derivative is notated as f prime. And then also in class, we were given an a value, and so the difference quotient was written with an a instead of an x. So this time, instead of our final answer being a number, it's going to sometimes be an equation that represents the derivative in general, so that I can use that to find the slope at any point on the graph instead of just one particular x value. So the way we apply this definition is you'll be asked to differentiate, which means find the derivative of a function. So for example, we have f of x equals x cubed. And so I would use that definition of a derivative to find the derivative of x cubed. And the way I would do that using this setup, this difference quotient, that's what we call the f of x plus h minus f of x over h. To start with, what we would do is rewrite the limit to use the particular function that they've given us. And so if my function is x cubed, I would write for the f of x plus h all cubed, and then minus f of x would just be minus x cubed. So my limit would look like this. The limit as h approaches 0 of x plus h all cubed minus x cubed over h. And then if I tried to evaluate this limit as it's written, it would be undefined because of the h on the bottom. So what I would need to do is simplify, and I would start by cubing x plus h first and then seeing if anything cancels. So once I cube x plus h, my resulting polynomial is x cubed plus 3x squared h plus 3x squared plus h cubed minus x cubed. My x cubes would cancel, x cubed. And then what I notice is the resulting three terms each have h's in them. They each have at least one h, so I could I could cancel that h, reduce the 2 to a 1, and change this 3 to a 2. And so from there, after simplifying and cleaning it up a little bit, my resulting limit would be the limit as h approaches 0 of 3x squared plus 3xh plus h squared all over h. Oh, nope, that's not correct because I eliminated the h in the denominator as well. So actually it would be the limit as h approaches 0 of 3x squared plus 3xh plus h squared. And so from there, I can use substitution now because I would get a defined expression. If I plug 0 in for h, these two terms would just equal 0, and I'd just be left with 3x squared. So once I have evaluated the limit, I now know that the derivative of f of x equals x cubed is 3x squared. So I can write my final answer in using the prime notation if I just include an f prime of x, and then equals 3x squared. And so that would be how I would use this formal definition of a derivative to differentiate a function. Before I end the video, I just want to include two really important items. The first one is the derivative at a point. Using that same formal definition of a derivative, instead of having the x plus h and the x, we switch it up. We're going to be given a particular x value. And so instead of completing this whole process and then plugging the x value in at the end, instead I could do it all at once by using this form. So we change it up where it's x approaching that x value. Here, that's what the limit is evaluating it. And then from there, it would be f of x minus f of a over x minus a, which is pretty much like the formula for slope, y2 minus y1 over x2 minus x1. And so this would be one way that you could use the limit definition to get the slope at a point directly instead of finding the derivative and then evaluating. The other item is just informative piece where I just want to make you all aware of the different ways you may see the derivative notated. So what we have used so far is the prime notation, f prime of x. However, you may see it written other ways. So if they want you to find the derivative, or they want to indicate that something is the derivative, you could see it written in this way. It's just y prime. So instead of f prime of x, using y prime. But it does not indicate your independent variable. So even though we know we're looking at a derivative, we don't know what we took the derivative with respect to. And so it's not as much information. You could also see this version. So sometimes you'll hear it read as dy over dx. It's the derivative of y with respect to x. So that gives you a little more information about what this means. But it's just an alternative to f prime of x. These are called differentials, and we will go into more detail about those in a later unit. You could also see written as, instead of dy over dx, you could see it as df over dx. This is the derivative of f with respect to x, so it just emphasizes that the function's name is f, or the function's name is g, instead of using the generic y. That comes in handy when you have multiple functions that you're looking at the same time. And then you could see your derivative notation written in this way, which is the derivative of f of x with respect to x. So it's just more information showing that you have a function that the independent variable is x, and this is the derivative with respect to x. So you have lots of options of how to communicate that an equation represents the derivative, or that you're expected to find the derivative of a function. And so there's your introduction to the formal definition of a derivative and a few details about derivatives in general.